For millennia, humanity has gazed up at the stars, marveling at their beauty and mystery. Stars, the fiery celestial bodies that light up our night sky, are powered by nuclear fusion, converting hydrogen into helium in a continuous, energy-releasing process. But like all things in the universe, stars have a finite lifespan. Eventually, they will run out of fuel, cool down, and die, often resulting in spectacular supernovas or gradually fading into white dwarfs. However, recent scientific inquiries have opened up an exciting possibility. What if some stars could live forever? The idea that dark matter, one of the most elusive and mysterious substances in the universe, might enable stars to achieve immortality is a topic that has fascinated astrophysicists in recent years. But how could dark matter make stars eternal, and what implications would such a discovery have for our understanding of the cosmos? To grasp how dark matter might allow stars to live indefinitely, it's important to first understand how normal stars operate and evolve. Stars are born from vast clouds of gas and dust, which collapse under their own gravity to form hot, dense regions known as protostars. Once the core of a protostar becomes hot enough, nuclear fusion ignites, and a full-fledged star is born. The length of a star's life depends largely on its mass. Larger stars burn through their fuel much faster than smaller ones. A star like our Sun will live for about 10 billion years before it starts to expand into a red giant, shedding its outer layers and eventually collapsing into a white dwarf. Massive stars, on the other hand, may only live a few million years before exploding in a supernova and leaving behind a neutron star or black hole. But no matter their size, all stars share a common fate: eventual death. This is because stars rely on a limited supply of fuel, primarily hydrogen. Once that fuel is exhausted, the fusion process that powers the star stops, and the star cools and dims. In a universe governed only by ordinary matter, all stars must eventually die. The invisible majority. Dark matter plays a pivotal role in this story of potential stellar immortality. Although it makes up approximately 85% of the matter in the universe, we cannot directly observe dark matter. It does not emit, absorb, or reflect light, which is why it's called dark. Instead, dark matter reveals its presence through its gravitational effects on visible objects, such as stars and galaxies. Scientists have detected dark matter by observing how galaxies rotate and how light bends around massive objects in space, a phenomenon known as gravitational lensing. Without dark matter, the outer edges of galaxies would spin much slower than the inner regions. Instead, galaxies appear to have far more mass than we can see, suggesting that dark matter surrounds them like an invisible halo, holding them together. But while we know dark matter is abundant, we don't yet understand its exact nature. Is it made up of exotic particles? Does it interact with regular matter in ways we have yet to detect? These questions remain some of the greatest mysteries of modern astrophysics. What's intriguing, however, is that dark matter might not just affect galaxies on a cosmic scale. It could also influence the lives of individual stars. The theoretical connection. So how could dark matter make stars live forever? The idea hinges on the possibility that dark matter could provide stars with a supplementary source of energy long after their regular nuclear fuel is exhausted. Here's how it might work. Some theories suggest that certain types of dark matter particles, if they exist, could interact with regular matter in specific ways. These interactions might generate heat in the core of stars, thereby slowing or even halting the cooling process that would otherwise lead to their demise. One potential candidate for these interactions is a hypothetical type of dark matter particle called a weakly interacting massive particle, WIMP. WIMPs are thought to interact with ordinary matter via the weak nuclear force, one of the 4 fundamental forces of nature, albeit very rarely. If WIMPs were to accumulate in the core of a star, they could occasionally collide with normal particles, releasing small amounts of energy in the process. This energy could supplement the star's usual energy production, effectively giving the star a new source of power once its hydrogen and helium reserves are depleted. If enough dark matter accumulated in a star, this process could theoretically continue indefinitely, allowing the star to maintain its luminosity for far longer than it otherwise would. In this scenario, dark matter could extend a star's life. not just by millions or billions of years, but potentially forever. A star powered by dark matter could achieve a kind of immortality, shining in the cosmos for eternity. Another possible mechanism through which dark matter could create immortal stars lies in the conditions of the early universe. Shortly after the Big Bang, the universe was a much denser and hotter place. Dark matter was more concentrated, and its interactions with ordinary matter could have been more frequent. In the early universe, stars might have formed in regions of space where dark matter was especially abundant. These dark matter-rich environments could have provided an additional source of heat to newly formed stars, allowing them to shine much longer than stars that formed in regions with less dark matter. In fact, some researchers have speculated that dark stars might have existed in the early universe. These stars, formed from both ordinary matter and dark matter, could have been powered primarily by dark matter interactions rather than by nuclear fusion. While these dark stars may no longer exist today, their remnants could still be scattered throughout the universe, providing tantalizing clues to the role dark matter played in the early cosmos. Observing the unobservable, how we might find dark matter stars. If dark matter can make stars live forever, how could we prove it? Observing such stars would be extraordinarily difficult, given that dark matter is invisible and that its interactions with normal matter are extremely weak. However, there are some indirect ways we might detect the influence of dark matter on stars. One method involves looking for stars that seem to defy the usual expectations of stellar evolution. A star that continues to shine brightly long after it should have died could be a strong candidate for a dark matter-powered star. Additionally, astronomers could search for signs of dark matter particles interacting with ordinary matter in the cores of stars. For example, certain types of WIMP interactions could leave detectable signatures in the form of specific radiation or particle emissions. Another approach involves studying the distribution of stars in regions of space where dark matter is believed to be especially abundant, such as the centers of galaxies or galaxy clusters. If stars in these regions appear to live longer than expected, it could be a sign that dark matter is extending their lifespans. Finally, future advancements in particle physics could help us better understand the properties of dark matter and how it interacts with ordinary matter. Experiments such as those conducted at the Large Hadron Collider or in underground dark matter detectors could reveal new insights into dark matter's behavior, potentially confirming its role in stellar immortality. If dark matter can indeed make stars live forever, it would represent a groundbreaking discovery in both astrophysics and cosmology. For one, it would dramatically alter our understanding of stellar evolution, showing that stars are not necessarily doomed to die when their nuclear fuel runs out. It would also provide new insights into the nature of dark matter and its interactions with the rest of the universe. Moreover, the existence of immortal stars could have profound implications for the future of the universe. In a universe where some stars never die, there would be a perpetual source of light and energy, even as other stars fade away. Over trillions of years, as ordinary stars exhaust their fuel and turn into cold remnants, dark matter-powered stars could continue to shine, providing islands of warmth and energy in an otherwise dark and lifeless cosmos. This vision of a universe filled with immortal suns might seem like science fiction, but it's rooted in cutting-edge theoretical physics. While we're still far from proving that dark matter can make stars live forever, the possibility is tantalizing. It challenges our current understanding of the universe and opens up exciting new avenues for exploration. Whether or not immortal stars exist, the search for dark matter and its role in the cosmos continues to be one of the most thrilling scientific endeavors of our time. The idea that dark matter could make stars live forever is a bold and intriguing one. While still speculative, it offers a fascinating glimpse into the potential ways in which dark matter might shape the universe on both cosmic and stellar scales. As our understanding of dark matter improves, we may one day discover that some stars, powered by this mysterious substance, are destined to shine for eternity. And in a universe where so much is temporary, the thought of eternal suns is both awe-inspiring and humbling. The stars, it seems, may have more secrets to reveal than we ever imagined.